Objective 4 is find explicit formulas. These explicit formulas are used to find the nth term of any sequence. And like I mentioned earlier, there's two different types of sequences that we've been working with, arithmetic and geometric, so that means as well that there's two different types of explicit formulas, arithmetic and geometric. And I've listed both of the parent formulas here, highlighted in yellow. Let's start with the arithmetic sequence. The parent formula for any arithmetic sequence given to you is a sub n equals a sub 1 plus d times n minus 1. Now, if you notice, a sub 1 and d are in different colors, and I did that just to highlight that these are very important pieces of the formula because they will change based on the given sequence that is put in front of you. So any given sequence will have its own specific explicit formula. So a sub 1 represents the first term that is listed in the sequence. And d, we've already talked about, is the common difference. So when you're coming up with the explicit formula for any sequence given to you, you're going to have to find both a sub 1 and d to find the specific formula. Now, let's jump over to the geometric sequence. The formula is given to you, a sub n equals a sub 1 times now. So one major difference that I see already. Arithmetic is addition, just like the common difference is addition. Geometric is multiplication, a sub 1 times r, just like the common ratio is multiplication. The other difference is arithmetic sequence has a d, geometric sequence has an r, and then finally, the n minus 1 in the geometric sequence is in the powers. So if you notice this right here, n minus 1 is in the powers. It's another key difference between the two formulas, because eventually you might have to be able to tell me the differences between the two formulas. And so again, arithmetic has a d, geometric has r, arithmetic is adding, geometric is multiplying, and finally geometric has the n in the powers as well. Now, same thing, a sub 1 for the geometric is the first term listed, or the initial term. And the r represents, we've already talked about this as well, the common ratio. So at this point, I've described everything that you will need to know for any given explicit formula. And I'm about to show you then how to derive an explicit formula if given an arithmetic sequence and if given a geometric sequence. Similar process for both, you're just finding different pieces. So let's do the arithmetic first. I will do the I do problem. I'll ask you to pause the video and try the you do problem on your own to check your understanding. So for the I do problem, the first things I have to do, the first step, is I have to identify my unknown variables of the parent explicit formula. So I'm referring to this the whole time. And I mentioned earlier the unknown variables are a sub 1 and d. So my first step is to identify what is a sub 1. And I already wrote that a sub 1 represents the first term listed in this given sequence. So the first term listed in this sequence is negative 9. So my a sub 1 is negative 9. Now I have to find the d as well as my other unknown variable. So in order to find the d, there is some math that needs to be done, and I'll show that math over here to the right. Remember, in order to find a common difference, you have to take any given term of the sequence and subtract the term before it from it. I'm going to take the second term. I'll do this in blue. The second term is negative 2. And I have to subtract the term before it, which is the first term, negative 9. So negative 2 minus a negative 9 equals, again, when you subtract the negative, it becomes positive. So negative 2 plus 9 is a 7. So my common difference in this case is 7. We can check that math if we want to. I can then move on to the next term, the third term, which is 5, and subtract the term before it, which is negative 2. So 5 minus a negative 2 plus a plus, so 5 plus 2 is 7. So the common difference in this case is indeed 7. So my first step is done. I've identified both pieces of the formula that I needed to in order to come up with the specific explicit formula for this given sequence. sequence. My second step then, so I'll write my first step, right here, identify that. Second step then is just to write out the actual explicit formula for this sequence. So I'm going to base it off of this again. So I'm going to write a sub n equals a sub 1, but instead of a sub 1, I'm going to put negative 9, because I found that earlier. Negative 9 plus 7, my common difference, times n minus 1. So go ahead and pause the video and try to come up with the explicit formula for number 2 on your own. At this point, you should have paused the video and tried number 2 on your own. I have squared my answer of the explicit formula that I got for this given sequence, and it's a sub n equals 2 plus 4 times n minus 1. Let's go over, again, how I got that. The first term, a sub 1, is 2. So I got a sub 1. And my common difference, d, is, I showed my math over here. I took the second term minus the first term, 6 minus 2 equals 4. Then the third term minus the second term, 10 minus 6 equals 4. That's how I found d as well. Now, just to reiterate, now that I have this explicit formula, if I wanted to find the 50th term, I would say a sub 50 equals 2 plus 4 times, I hope you can see this now, instead of n, I would write 50, because I want to find the 50th term. Now, let's move on to geometric over here. I'm going to do the I do problem, and I'll have you try one on your own. So it's a similar process again. The first step is I have to identify a sub 1, and instead of d now, I'm going to have to identify the common ratio. So my a sub 1 is pretty simple. It's the first term listed. In this case, it's 2. The common ratio, I have to do a little bit of side math. I'm going to take the second term of my sequence, which is 4, and I'm going to divide it now by the first term of my sequence, so the term before it, which is 2. 4 divided by 2 is 2. Let's just check that math. Now I'm going to move on to the third term in my sequence. 8 divided by the term before it, the second term, which is 4. So 8 divided by 4 is also 2. They're the same, so I know that my common ratio, or R, is also 2 in this case. So I'm done with the first step. Second step then is to input my 2 values I just found into the parent explicit formula from up here to get the very specific explicit formula for this sequence. So I'm going to write a sub n, because I don't know that, equals my a sub 1, which is 2, times my r, which in this case is also 2, raised to the n minus 1. And that is my explicit formula. So, go ahead and try the you do problem on your own. So pause the video and try that one on your own, and then unpause it to check your answer with mine. At this point, you should have paused the video to try this problem on your own. Here's my work. I've done step 1 and step 2, and I got the explicit formula that I'm about to square in here. So please check your answer with mine to make sure you got it correct. If it looks anything different than that, please raise your hand so I can come over and talk to you about it. Or again, if I'm unavailable, please ask one of your neighbors to see if they can help you as well. Now, let's talk quickly. If you notice, I did the math to find my common ratio. I took the second term divided by the first term. 9 divided by a negative 3, there's only one negative. And anytime it's multiplication or division, if there is a negative in just one of them, the answer is also negative. And then if I do my other work, the third term divided by the second term, same thing. Negative 27 divided by 9, there's only one negative, so my answer is negative 3. And I do want you to get in the habit of doing this as well, because this is very important for the entire length of the semester. Whenever a number or a base is raised to an exponent and it is negative, please put it in parentheses. So you get in the habit of knowing that you have to square that negative or raise that negative to a power, depending on what the power is as well. All right, let's move on to the final piece of this objective. Now, the whole point of finding an explicit formula is, again, to reiterate what I said earlier, to find any given term in a sequence. So if I wanted to find the 2000th term in a sequence, instead of having to do the process of listing out all the 2,000 terms in the sequence, I could just use the explicit formula to find that term. I can actually input 2,000 in for my n and do the math to find the actual 2,000th term. But let's do something a little bit lower than that. So if I was going to answer this question, how to find a given term of an arithmetic sequence, I'm going to reference my I do problem, and I'm going to have you reference your you do problem. So I have, and I didn't box this in, it's right here. I have my arithmetic sequence that I'm going to use right here. So I'm going to rewrite that down here. A sub n equals -9 plus, what is that, a 7 times n minus 1. All right, that is the explicit formula. If I'm given that explicit formula, and let's say I want to find the 75th term, all right? So instead of writing a sub n now, I'm going to write a sub 75, because I want to find the 75th term, not the nth term. Now, the only difference here, the only thing I do differently, is I write the same explicit formula, a sub 75 equals -9 plus 7 times, instead of writing this n, I'm going to input 75 in for my n because I want to find the 75th term of this sequence. So 75 minus 1. To do this math, -9 plus 7 times parenthesis of 75 minus 1, I would get a sub 75, or the 75th term in this sequence, to be 509. So to put that into context, if I go back up to this sequence, this I do, -9, -2, 5, 12, 19, ... If I go all the way to the 75th term, this is the first, second, third, fourth, fifth. If I go all the way to the 75th term, that number would be 509. And I'm done. So I use my explicit formula to find a term way out into the distance, and I got my answer of 509. So I want you then to use the explicit formula you found in your you do problem. So please write this down. I'm going to have you do your you do problem. So a sub n equals 2 plus 4 times n minus 1. You're going to use that formula, and I want you again to find the find the 75th term in this sequence. So I want you to find a sub 75. Go ahead and pause the video and try that on your own. If you see, all I did was replace n with the 75th term. That's the one I want to find out. And I found that a sub 75 equals 298. Hopefully you got 298 for your answer. If not, please check with a neighbor or raise your hand and I will come over and check your work as well. Now, one more thing, I want to look at the I do of how to find a given term if given a geometric sequence. I'm going to do the I do problem over here. So I'm going to write a sub n equals my problem, which is 2 times 2 raised to the n minus 1. 2 times 2 raised to the n minus 1. And in this case, let's just say I want to find the 10th term, so a sub 10. All I'm going to do is replace n with 10. So 2 times 2 raised to the 10 minus 1. I can do this math, 10 minus 1, so then it goes to 2 times 2 raised to the 10 minus 1 is 9. So I'm going to do this math to find the 10th term in this sequence. So if I do that math, I'm going to find out that the 10th term in this sequence, 2 raised to the 9th is 512 times 2 is 10,024. So if I was going to list this sequence out, and the 10th term would be 10,024 right here. So pause the video and try the you do problem on your own. Use this explicit formula right here that you came up with in your own problem and try to find the 10th term of it. You should have paused the video to try this one on your own. I wanted to use this explicit formula right here and evaluate a sub 10. All I did was, for my n, I plugged in 10, and I shifted it over here. I did this math, 10 minus 1 is 9. That's how I got this. Then I did this math. I put that in my calculator exactly how I see it, and this is what I got from my answer. If If you didn't get that, please raise your hand.